Okay, good morning, you guys, or afternoon, I don't know, whenever you're watching this. All right, we're going to start lesson 8A, the tangent function. So we will finally be graphing tangent, all right? So hopefully this is going to work for us. All right, so we're going to start off just like we did with sine and cosine, talking about the definition of tangent. Remember that we determined that the tangent is the slope of the terminal ray. Okay, and remember the terminal ray is the one that swings around to make the theta, the angle. And it is the ratio of the change in y over the change in x. So it is y over x, or you could also say sine over cosine. Let's see. And notice that the slope values of the terminal ray repeat every 1/2 revolution of the circle. Okay, so the tangent function has a period of pi instead of 2 pi like sine and cosine. Okay, so that's what we just said. So here's our vocabulary. The tangent function is sine over cosine. This is the slope of the terminal ray of theta. The tangent curve is the graph, and tangent of theta is the ratio in the y's values to the change in the x values. Okay, so we're going to start out just like we did with sine and cosine, and we're going to fill in this table of values. We'll have one complete cycle from 0 to pi, unlike 2 pi with the others. So the period of tangent is pi. However, it also has vertical asymptotes, because remember, if we have a 0 in our denominator, then it's undefined, right? All right, so on what continuous interval can the entire behavior of the function be shown? So here we go. We're going to make our table from 0 to pi. Let's get up, there we go. So tangent of 0 is 0. At pi over 6 is square root of 3 over 3. 1 square root of 3. Okay, so at pi over 2, it does not exist, because if you remember, the ordered pair at pi over 2 is 0, 1. So 1 over 0 would be undefined. All right, so negative square root of 3, negative 1, negative square root of 3 over 3, and 0. Just like we did in the other two, we're going to state the intervals of x where y's are increasing. Okay, so obviously it's increasing here, okay, from 0 to pi over, well, actually that should not be equal then, to pi over 2. Okay, so notice my inequalities, equal there, not equal there, okay? And it is also increasing from here to here, okay? So from pi over 2. So in other words, it's always increasing, right? The y values never decrease, okay? And so this function is monotonic. Oops, monotonic, meaning it either never increases or never decreases. And it is increasing on its entire domain, okay? All right, so that's our tangent function. Let's see what's on the next page. We're gonna graph. Let's see, the graph of the tangent function will complete one full cycle in the interval of 0 to pi. So we're gonna put in our vertical asymptotes at pi over 2. So let's do that in red. Let's see, we'll do it in that. So we have a vertical asymptote there. We have one there. Okay. And then we have it here. Oh gosh, that's not very good. Okay, there we go. And there. Okay, so there are our asymptotes. The first question says, on what continuous interval can the entire behavior of the function be shown? Okay, so on the interval negative pi over 2 to pi over 2. Okay, sorry, that should be a negative pi over 2 right there. Okay, And then it says find the points of inflection. Okay, so if we're going to graph this function, we can look over it. We can go back to our table and graph it from there. So this is what our tan function would look like. It's at 0, and then at pi over 4, it's at 1, and negative pi over 4, it's at 1, okay? And that is just going to repeat every single time, okay? So there it is. So tangent rises from left to right, okay? It's increasing. Cotangent is decreasing. It's the opposite, okay? And you could do it here too if you wish, like that, and like that. Okay, so there's our tangent function. And our points of inflection are here, right, where it goes from concave down to concave up, right there, right in the middle. Okay, so our points of inflection are x equals 0, pi, negative pi, so it's every pi, which is the period, right? So you could say 0 plus or minus pi k. Actually, you don't need plus or minus if you say that k is an integer, because that's going to get the plus and the minus. Okay, so every pi, every period, it repeats that point of inflection. Okay, all right, so here are our characteristics of the tangent function. Our tangent function, the domain, okay, this is a little bit different. Bx cannot equal pi over 2. Now, we'll see that more when we start talking about how do we find our asymptotes for a tangent function. Okay, so we'll talk more about that, but k, oh my goodness, all right, k is an integer, okay? The range is all real numbers as it goes up and down to positive infinity, okay? So all this is saying is our domain, that is just saying our domain are all x's except for where our asymptotes are, okay? And we're going to be able to determine our asymptotes based on our parent function having asymptotes at pi over 2. So, like I said, I'll show you that. We'll get to that. Our x-intercepts are at pi k, okay? So 0, where k is an integer, and we can see that from our graph. Every pi, we have a x-intercept. Our y-intercept is 0, 0, okay? The symmetry, it is symmetric about the origin. Okay, so it's symmetric about origin, so that makes it odd. And the asymptotes are at pi over 2 plus pi k, right, where k is an integer. So every pi over 2, we have asymptote, and at pi over 2 plus every pi. And our key points, here we go. We haven't really talked about that for tangent. Here are our key points. You remember when we had sine and cosine, we had int, min, max, min, that stuff. Okay, so our key points for tangent, we have a vertical asymptote. Then we have a low point. Then we have an intercept. Then we have a high point. And then we have another vertical asymptote, okay? Okay, so here it is. You can see vertical asymptote, low, intercept, high, vertical asymptote. Okay? All right. Graph the function, state the period, and show all asymptotes. Okay. Well, remember, this is just y equals -1, right? You could put a -1 out there. Tangent of 1x. Okay, so your b is 1. Okay. So let's describe the behavior, and we need to show the period. Okay, so our period, remember, for tangent is pi. Okay, so pi equals pi over b. So we can find b, and b is 1, right? So our period is pi for this particular function. A is 1, but the negative caused the parent function to be reflected across the y-axis, and so it's decreasing on the domain, okay? So negative is a reflection and causes y to decrease on the domain, okay? All right, so our asymptotes are still going to be at pi over 2. That's not going to change in this particular one. So let's put them there. Pi over 2, 3 pi over 2, pi over 2, 3 pi over 2, okay? And instead of increasing, it's going to decrease. So it's going to go, remember, right in the middle, right in the middle is going to be that intercept, okay? Right in the middle, and that negative is going to cause it to flip-flop, okay? So we're going to go high, low, high, low, high, low, and this time our tangent function is going to look like that, okay? So there it is. And this is going to come in like that. All right, so there it is. All right, so that's tangent. And lastly, we have graphing variations of A tan bx, okay? All right, so let's see. We can, to find the 5 key features, okay, here they are. Find 2 consecutive asymptotes by setting the argument equal to the parent asymptote. So remember, the argument is in here. So that's where we're going to set that equal to negative pi over 2 and positive pi over 2, and we're going to get our asymptote. So if we can get our an asymptote here and an asymptote here, then we can identify our other 3 points. Midway, we're going to get our x-intercept, right? And then midway between, well, here we go, midway between our x-intercept and our asymptotes, sorry about that line, we're going to get our high and our low, okay? Just like we did with our sine and cosine, we split everything into equal intervals. You can do the same thing. So if you can find your asymptotes, okay, then you've got that space in between where you're going to divide it to find the, to find the intercept, low, and high, okay, all in equal intervals. And so this is what it looks like. So you can see, and that's if you have a minus c in the middle, but here, let's go do it. So key properties of tangent function, the domain is bx minus c cannot equal 0. That's what's going to give us our asymptote, okay? So that argument in there cannot equal 0. Our range is all real numbers. Our A value is our vertical stretch factor, just like it always is. Vertical stretch factor. Our period is pi over b instead of 2 pi over b. And then, of course, our key points, we said, are vertical asymptote, negative A, 0. I should probably not do that like that. Vertical asymptote, negative A, 0, A, positive A, vertical asymptote. Okay, so let's see what this looks like. All right, here we go. Use transformations, graph each function, state the period, show all the asymptotes. All right, so here we go. Now, let's find our asymptote. So remember, we set the inside argument right there. Let me scroll in. There we go. Equal to negative pi over 2, and that's going to find our first one, okay? And then we'll set it equal to positive pi over 2, and that's going to find our second asymptote, okay? So x equals negative pi and x equals positive pi. So those are our asymptotes, okay? So here we go, negative pi. Oops, sorry, I'm going to make that straighter. Oh, I don't know what happened down there. Negative pi and positive pi. Okay, negative pi and positive pi are asymptotes. Okay, so now if we can go halfway in the middle, which is right there at 0, we know that's going to be our 0. It has a negative, okay? So we got to remember that instead we're going to do high point first, right in between. High point, low point, okay? So there it is. Okay, sorry, it's not a beautiful graph, but it's good enough. And right here, it would be here and here, okay? And over here, it's going to be there and there. Okay, so it's come in like that. All right, so, yeah, all right. So there it is. There's our thing. So down here it says find your period. So remember, period is pi over b, and in this case, our b is 1/2. So our period is 2 pi, okay, which you can see that. This right here, oops, I should meant to do that in red. So this right here is one cycle of our tan, and that length is pi, okay? Okay, let's do one more. And here we go. So let's find our asymptotes. Okay, so we're going to say 1 or pi over 4 equals negative pi over 2. Okay, so, sorry, pi over 4x. Okay, so x, oh my goodness, x equals, come on, x equals negative 2. Okay, and then we have pi over 4. X equals positive pi over 2, and so x equals 2. So those are our asymptotes, 2 and negative 2. So I'm going to go over here, and there they are. Okay, and that asymptote repeats, okay, 1, 2, 1, 2, 3, there, equal intervals, and there. Okay, now go right in the middle, and that's going to be our 0. Now, is it have a negative out front? It does not. So in this case, our low is going to be first, right in the middle, and then our high. So I could do this on all of these. Oops, right there. Okay, and so it's going to come down like that, and come down like that, and come down like that. And there we go. There's our tangent function. The last thing we need to do is find the period. So it's pi over 4, and that equals 4. So our period is 4, which again, we can certainly see that on here. Negative 2 to 2 is 4. Okay, and that's one period of our tangent function. All right, so you guys, that's it. That was graphing tangent. I will see you guys on Friday, our half day. Okay, have a great day.